What up, mathletes? Whoop, whoop. All right, let's do this. We're finishing up day 2 of our 4.1 graphing. We're starting off today with a doozy. So we're doing graph of y equals a. Spoiler alert, anything that says x equals is not what we're talking about. Believe it or not, even though y is the up and down value, whenever you have a y equals a certain value, it's going to make a horizontal line. So y equals a is always going to be a horizontal line. Go ahead and put that in your notes. Horizontal line. I'm getting faster. Not necessarily nicer, but faster. Okay? So what is the horizontal line at? Well, if you look right here, what value is that? That's y equals 1, 2, 3, 4. That's y equals 4. Notice that no matter what x is, x could be 5, x could be -5 or -4, it doesn't matter. Y is always going to be 4. So in this case right here, we're going to have y equals 4. Let me exit this out, drag it down there. We're going to have y equals 4. And what do we have right here? Well, we're at 0, 0. If I go down, that's -1 for y, so that's going to be y equals -1. So whenever you're just left with y equals, the graph of a y equals anything is always going to be a horizontal line. Boom, right there. Check that action out. Anything else? Nope, we're good. Let's move this out of the way. I'm going to reset this so I don't forget later when I teach it. Now let's talk about x equals. If y equals is a horizontal line, then guess what x equals is? Bang! It's a vertical line. So that's going to be a vertical line always. By the way, everybody notice for the y equals is a function. That'll pass a horizontal line test. This is a vertical line. It will never pass a vertical line test. It's going to hit every part of that vertical line. So there's the difference there. But again, what are we looking for? X equals 1, 2, 3. No matter what y is, x is going to equal 3. That's a vertical line. And it's going to be at x equals 3. So let's go ahead, pull that in. X equals 3. What is this one? -1, -2, -3, -4. So that's going to be x equals -4. So again, x equals is always a vertical line. Y equals is always a horizontal line. And we see that that's correct. Again, let's reset that. And we're moving kind of quick on these because these don't need a lot of explanation. Just know that anything that's just, if it's a vertical line, it's going to be a y, x equals. If it's a horizontal line, it's going to be a y equals. Boom, 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 boom. Now we're going to start talking about graphing functions using intercepts. Remember, an x-intercept is always in the form of some value for x and 0 for y. X-intercepts, y is always 0. And the same thing, at a y-intercept, x is 0, and there's going to be some value of y. That's what it always is. So if I'm looking right here, I'm going to look for where is y 0? Where is y 0? Right here, which means this is going to be my x-intercept. And we also know an x-intercept is where it crosses the x-axis. Just like a y-intercept is where it crosses the y-axis. So that's going to be your y-intercept right here. Okay? Awesome sauce. Let's go ahead. Make sure you have those written in. I can always drag them there in case we need to come back and look at these. This is my x and y intercept. Ooh, check it. Yay! We'll make you listen to that sound. That's all we need to know for this. So let's reset that. I wasn't sure if there was more we needed to look at. Sometimes I forget. So we're going to do more about using intercepts. Now we got to find out, how do we find our intercepts? Well, there's a very nice, easy way to do it. If I look right here, graph using intercepts, identify the x and y intercepts. So first thing I'm going to do is I'm going to take that 2x minus 5y equals 30. And to solve for the intercepts, well, again, for an x-intercept, what do I know? I know that y equals 0, right? So because of that, let's solve it. I'm going to have 2x minus 5 times 0 equals 30. And anything times 0 is 0. I just have 2x equals 30. Divide both sides by 2. And I get that x equals 15. So I know that my x-intercept is at 15, 0. Now let's do the y-intercept. My y-intercept is where x equals 0. So same equation, but instead I'm going to have 2 times 0. I'm going to plug in 0 for x minus 5y equals 30. Okay? Again, that goes to 0. I'm going to divide both sides by negative 5. 30 divided by negative 5, well, positive divided by negative is negative. And 30 divided by 5 is 6, so that's going to be negative 6. Which means my y-intercept is, I don't know why I just did that. It's going to be at 0, negative 6. Okay? So let's look over here. Which one is it? X-intercepts at 15, boom. Y-intercepts at negative 6. So I'm going to erase all this. Make sure you pause it if you need to write it down. But we know it's right here, 15, negative 6. Boom, check it. Yeah. And then let's graph it. Here's how I'm going to graph it. If my x-intercept's at 15, let's go to 15 on the x-axis. And if my y-intercept is at, where's my y-intercept at? Negative 6. Let's go to negative 6 on the y-axis. And now let's connect our line. See how those are the only 2 points I actually needed? So this is a really simple way to graph using the intercepts. Intercepts are super powerful. And there we have our graph. I prefer using that if I can as opposed to a table. It's nice. All right. And last but certainly not least, we're going to try it one more time. Do a little extra example. In fact, take a minute. Let's look at this. Well, let's read it out first. Troy is leasing an art gallery for a month to display and sell his paintings. He spends $500 to lease the gallery and plans to sell each painting for $60. The function y equals 60x minus 500 represents the amount of money Troy has made y after selling x paintings. Which part of the graph uses the x and y intercepts correctly to graph the equation? Well, let's find out. If it's an x-intercept, what do I know? I know that for the x-intercept, I'm going to set my y equal to 0. And I know for my y-intercept, I know that my x equals 0. I'm actually going to do y-intercept first. When it's in this form of y equals, it's easier to find the y-intercept. Check this out. It's always going to work out like this. I'm going to have y equals 60 times 0. Minus 500. Gotta do better at making my zeros not look like 6s. Okay, so anything times 0 is 0, and I'm just left with negative 500. So let's find out which one of these graphs is at y equals negative 500. Now, go with me on this for a second. Notice that no matter what x is like, no matter what's times x, if x is 0, it's going to end up being 0. Whenever you're in this form, this is called the y equals mx plus b. The name for this form is called slope-intercept. The reason why, it's called slope-intercept form. The reason why is because your m is your slope, and your B is your intercept. We'll talk more about that later, but just know that that's always going to be your y-intercept, which makes it real nice. Okay, but again, this is just stuff to know. We'll talk more about it at a later date. I'm going to erase this, write down what you can, pause if you need to, boom. Let's go down here. I need to find where is negative 500 on the y. So I'm looking at the up and down the y. There's one at negative 500 there on the y. This has a negative 500, but it's on the x-axis. That's wrong. So far, A is the only one that has it right. I see a point at negative 500, but that's a point. I need a line. This has a point negative 500, and I bet if we solve it, that's 8 point something for this x-intercept. That's probably the right x-intercept. The thing is the only one that actually graphs it on the y-axis at negative 500 and makes a line is this A, so we can use that. We could have also solved for our x-intercept by plugging in 0 for y. If we did that, just so you know, we would have got 0 equals 60x minus 500. I would have added 500 to both sides, right? I can't believe it. I didn't cross my zeros. I just like to cross my zeros. It makes me feel happy. So plus 500. And I get 500 equals 60x. Divide both sides by 60. 50 divided by 6, I don't know. It's going to be 8 point something. And the damn calculator out. 50 divided by 6 is 8.33, 8 1/3. Or just x equals approximately 8.33, which is what we see right down here. So we're going to look for that about a little past 8.33 right there. Again, that's another way of confirming this is our line. And now, because we're talking about money, and x is the amount of money, or no, x is the amount of paintings, excuse me, you can't sell a negative amount of paintings, which is why this graph stops at 0 on the x-axis. We can only sell a positive amount of paintings, and boom, go from there. So, check answer. Boom. And what does this tell us? This means that he's got to sell at least 8 paintings to break even. Actually, 9 paintings, right? Because it takes 8 1/3 paintings. So 9 paintings to start making a profit. But then after that, he's going to go up pretty quick. So that's what we can read from this situation. Awesome. Well, that's the rest of today's lesson. With that said, peace out.